Write an equation, slope-intercept form of the line. Okay, this is another Unit 5 review. Okay, so equation, we got the y by itself, we got a space in front of an x that I have to find a number for, that's your m space, and then another space, that's your b space. So I got to find the slope and the y-intercept because that's m and that's b. Okay, now from a graph, we actually want to find the y-intercept first, okay, because I'm able to look at a graph because that's y, okay. So I'm going to put b equals, and I just have to go down, mark the point it crosses, and then count how far up that is from the middle. So positive 1, positive 2, positive 3, positive 4, positive 5. So b is 5. B, 5. Now that's going to be point number 1. Now we're going to go forward and see if we can get another point, which I can right there, and that's point 2. Okay. So remember what a slope is on a graphed line. It's rise over run. Don't do that y minus y, x minus x from a graph, okay? Because you can measure the rise over run yourself. So you're down 2, negative 1, negative 2. And you're 3 forward, 1, 2, 3. Okay? So it's negative 2 is the rise, and then the run forward was 3. Okay? So negative 2 thirds. So y equals negative 2/3 x plus 5. That's the answer to that. Y equals blank x plus blank. So m, b. So slope, y at. Okay, so slope is m, the y-intercept's b. Now let's find the b first. From with the graphed line, I don't need any formulas here. Okay, so y going to right there. Okay, so your b 1, 2, 3, 4 this time. So b is 4. Okay, so then the slope is the ratio of rise over run of the line. Okay, which I can call that point 1. And then find another point right there is probably the best one. You want to go as close as you can, then you won't have to reduce the fraction. Okay, that's up 1 and forward 2. Okay, so 1 over 2. Positive 1 over 2, okay, because it went up. So that's your equation. Y is equal to 1/2 x plus 4. Okay, number 3. Now we're actually graphing the equations. Okay. Number 3, y is equal to negative 2x plus 6. Because y and x are both here, so I want to use the slope y at. So that's m, that's b. Okay, so m is negative 2, make that a 1, and then y-intercept is plus 6. Okay, so on your y-axis, go up to 6. 1, 2, 3, 4, 5, 6. And then your slope, negative 2. Remember, that goes with 1, so that's forward 1, down 2. And I would go down 2, forward 1, down 2, forward 1. Okay, or forward 1, down 2. It doesn't matter. Then I take my straight edge and I plot, make the line. Because on that line, it's continuous. Any point, any x, y point on the line fits this equation for x and y. Okay, number 4. Negative 4x plus 3y equals 24. Okay, I got x and y here. So slope, y at, but I don't know my m and b yet because I have to get the y by itself. So I put a multiplication. It's positive. I want it positive, okay? I don't have to do the opposite rule. Remember, if that was a negative 3, I'd make all of these into their opposites, but you know what, it's not. So I add 4x. Then I have to have an x on that other side. So to add 2, 0 works. So plus 4x. So you got 3 times y. Now I put the x down. 0 plus 4 is 4. And then plus the 24. going to divide all these by 3. Okay, so now I got y. Well, I put my x down. 4 divided by 3 is a decimal, so I want to keep that as a fraction because that's your m. Then 24 divided by 3 is 8, that's your b. Now the y is by itself, so 4/3 and 8. Now, I wouldn't do this to you on a test probably, okay? But hold on, we're not just going to say to heck with it. We need to make this worth 2's because you'd go to 8, 1, 2, 3, 4, 5, 6, 7, 8. Then you'd have to go up 4, forward 3. Well, you'd run out of room. So we're going to go by 2's here. We're going to go by 1's on there. So 8, 2, 4, 6, 8. Okay, so again, that's 8 right there. If you just put 2's, I'll know that's at 8. Then we're forward 3, up 4. Up 4, forward 1, 2, 3. Okay, can't do it again, but hey, at least I got 2. So that's how to handle that little problem. And if you make the y-intercept first and you're like, crap, I'm out the graph, then just erase it and put 2's. Okay, number 5, x equals -4. Now in the last video, okay, we're not doing slope y-intercept, okay, because only one of the variables is here. Y, not here, okay. So y can be whatever. I like to do 1, 2, 3, and so forth. Okay, now I stack 3 coordinates. Now you can stack as many as you want. I usually just go 3, okay. So x is -4. Because that's the letter that is there, that's always -4 throughout the whole thing. And then y not being there means y goes from point to point. So -4, 1, so I go backwards 4, up 1. -4, 2, backwards 4, up 2. -4, 3, backwards 4, up 3. And please make a continuous line, because it is continuous, okay? I mean, I can put decimals in for y too, okay? But we are always at -4 on the x-axis, okay? Okay, 6 through 9. The problems are all different on 6 through 9, but it's the same setup, okay? So that would be done on notebook paper or in the packet. So 6, I'm going to write them all down first. It says m is 1/3, remember m means slope, through 9, -3. Number 7, through 3, -2, and 6, 1. Number 8, parallel to y equals 5x minus 2 through 3, 5. Okay. Number 9, perpendicular to y equals -3x plus 7 through, or sorry, I got that with this one I wrote down wrong. Okay, 5x minus 2, it's 2, -1. Okay, and then 3, 5. Now, every single one of these, okay, the equation has the y in front, a space with an x plus another space. That's every single one of these, okay? We have the m and the b. So we got to find what goes in for m and b on all these, and that's the answer, okay? M, b. Now, m is the slope. Know what you're finding. B is the y-intercept. Now, the m's here, 1/3, okay? So 1/3. But the b we don't know. Again, I'm going to repeat this again. I've repeated it many times. 9, -3 is has nothing to do with the y-intercept, because that's, remember, to have it be the y-intercept, it's got to cross the y-axis. The point 9, -3, that is not even close to the y-axis. So we can't just say that. The go-to for your b is y equals m times x plus b. So my m is 1/3. And then for y and x, -3 goes in for y, and then 9 goes in for x. So you drop your plus, you put your b. Then you take 1/3 times 9, that's 3. Now get your plus 3, positive 3 to 0, so minus 3. Negative 3 minus 3 is negative 6. Okay. Okay, so y equals 1/3 x plus negative 6. Now, if you want to check your answer, you can punch in 1/3 times, and let's have 9 go in for x, and then plus negative 6. When I hit equals, I should get negative 3, which I do, because that's an input, output. Okay, input for x, output negative 2, input, output. Okay, so MB, slope, y. Well, this time they didn't give us the slope, okay? So I use my y minus y. They gave me 2 points, so to find the slope, I do y minus y, x minus x. Now look at your x's. We have a 3 and a 6, so we're going to start with the 6. So 6 on bottom, it's partner 1 on top. Then 3 on bottom, it's partner negative 2 on top. That's a plus plus, that's a plus negative. So it's 3 over 3. Just divide it, okay? It's 1, yeah, 1 over 1, but I don't have to graph it, okay? So I'm just going to put 1. When you put it in the equation, just write it. B, y equals m times x plus b. So m is 1. And we'll use 1 goes in for y, 6 goes in for x. You can also use this too, you get the same thing. So 1, drop your plus, put the b in front. 1 times 6 is 6. Minus 6, minus 6, negative 5 equals b. Okay. Alright, now if you want to check your answer, you got 1 times. We'll put 3 in for x first, and then we'll add negative 5. And it better be negative 2, which it is. Now I'm going to click the up key on the compass, go over the 3. And now I'm going to put 6 in. And hopefully now when I click equals, we're at 1. Aha. Okay. Alright, next one. Set up your y equals space x plus space m space x plus b space. Okay. So m, b. M is the slope. B is the y-end. Okay, let's talk slope. Now parallel, something go with parallel lines have the same m, okay? So what's the m to this equation? Well, y is by itself, so this would be m, this would be b. I don't need the b, okay? I don't use that at all. I don't care if that's minus 2, I don't care if it's negative 65, I don't care if it's 1200, okay? Same m, so this would also have a slope of 5. Okay, then the y-intercept, y equals m times x plus b. So my m's going to be 5. Okay, negative 1 goes in for y, and then 2 goes in for x. So b, 5 times 2 is 10. Get the positive 10 to 0 by minusing 10, and you get negative 11 equals b. So y is equal to 5x plus negative 11. Now let's see if that's right. 5 times 2 goes in for x plus negative 11. I got negative 1. Okay, next one. Y equals blank x plus blank. Okay, you got MB. Now perpendicular is different than parallel. Okay, they don't have the same slope. That means the two lines, this line and this line, cross at a right angle. All you really need to know though is that you flip your M, and make opposite. Flip M, make opposite. So what's the M to this equation? MB. You don't need the plus 7. Well, this needs to be a fraction so I can flip it. So how do I make a whole number a fraction? Well, we put a 1 under it. Now flip it to 1 over 3. So we flip the M, now we got to make it opposite. So it was negative, now it's going to be positive here. So 1/3, you don't need to put the plus in front of it. Then I proceed about business as normal. So M is 1/3, and 5 goes for Y, 3 goes for X. 1/3 times 3 is 1, so minus 1. Minus 1, 4 equals B. Now if I want to test that answer out, I go 1/3 times 3, because X is 3, 3 goes in for X plus 4. When I click equals, the output better be 5. Well, helps if you get it in right to your calculator. 1/3 times, again, that syntax error means you're not punching something in right. Okay, there's nothing wrong with the problem. It's just, 5. Okay, then my favorite problems, my personal favorite problems, are these kick butt V graphs that are valuable to everybody. Okay. Alright, y equals absolute value x minus 2. Okay, so I'll remind you on the test about, I'll have that up in the corner, parent graph, y equals absolute value x. So you would want to make your parent table, an input-output table for the parent function. You can just go 3 through -3. So if I put 3 in, it's 3. 2, 1, 0, 1, 2, 3. Because you put all those in for x, their absolute value ends up as positive because that's distance from 0. Now, let's box that up. There's nothing inside there, so x stays the same. We got this k value outside. Remember, outside, adding, subtracting outside is a k value. Okay, so k value means we add -2 to all of our y outputs. So 3 plus -2 is 1, 2 plus -2 is 0. 1 plus -1 is -1, 0 plus -2 is -2. 1 plus -2 is -1. 2 plus -2 is 0. 3 plus -2 is 1. Then I graph them. So 3, 1, 2, 0, 1, -1, 0, -2, -1, -1, -2, 0, -3, 3. So from the parent function, every point is translated down 2 units, which is what a k does. A minus k translates it down, a plus k translates it up. But I don't want you to try to memorize that. Okay, Matt, this is not about memorization, it's about following a logical process. Okay, y equals absolute value x plus 3. I'm going with the same parent function. Again, anytime you're graphing an absolute value function, you want to go based off the parent function. So 3, 2, 1, 0, -1, -2, -3. Okay, now what's up? Well, got it inside. Now it's an h value. How do you, okay, whoops, I jumped the gun. You got to put your outputs first. Then box it up. That's an h value. What do you do with h values? Well, then we know we have to translate the x on h values, but not plus 3. You set that inside equal to 0, and then find what x value makes that 0, okay? So, -3, -3, so x is -3. It's like I'm trying to cancel out the plus 3 with the x, okay? Because that's what you're trying to do with the h. So you're going to add -3 to all of these. So 3 plus -3 is 0. 2 plus -3 is -1. It's going to be -2, -3, -4, -5, -6. Now if you need proof to why you do that, okay, pick a number. Let's pick -5. Okay, here, I'll write it on paper, okay? I'll put -5 in for x plus 3. So we got to figure that out. So it's going to be -2, but it pops out of the absolute value as 2. So does -5 go with 2? Ha-ha! Yep, okay. So that's why the h values, you got to take the expression off to the side and line it up equal to 0 and find the x value that would make that 0. -3, okay? Because we want to get back to 0 here in the middle, okay? So 0, 3, 1, 2, 3. 1, 2. 2, 1. 3, 0. Then up again. Again, h values translate it left, right, okay? Actually, the opposite of what you'd think, okay? Plus 3, but left 3. That's why that's hard to memorize. You don't do that. You just need to label, box it up, label whether the number's an h or a k, okay? K's we just add to the y's. H's we need to bring the expression here equal to 0, make it -3, okay? Because K values I want to put as they are. H values, it's like you're trying to cancel out the operation. So you end up really adding the opposite of what's in there. But K values, you just add what's there. Okay, story problem time. Everybody's favorite time. Actually, story problems, I kind of like these ones. Temperature at sunrise is 65 degrees. Each hour the temperature rises 5 degrees. That means per hour. Each means per. Okay. Write an equation in slope-intercept form that models the temperature during the day. How many hours will it take the temperature to reach 90 degrees at that rate, assuming it stays at the same rate? So we got hours and degrees. So X is hours, Y is degrees. So per, we got degrees per hour. Okay, degrees per hour, that's 5. 5 times X. Each hour means per hour. So I make my table. So hours is X, degrees is Y. Okay, do I do the 0, 1, 2 or the 0 block? Well, since I have a number here in the per hour, let's go 0, 1, 2 and then do the block. Okay, so we have our B amount. We have 65, so I don't need B. Okay, 65 is ready to go at the beginning of the line. Then I start adding 5, that's 70, and then 75. Okay, now under the table, we put our closing amount, 90 degrees, and I'm finding the hours that go with that. Okay, line equals Y, so you got 65 plus 5 times X. Okay, and you got 65 plus 5 times X equals Y. So put the closing amount. Y equals the closing amount, 90. So 65 plus 5 times X equals 90. So plus and times, so you get your 65 to 0. So that's 25 degrees. Then you divide both sides by 5, and we have our answer 5. Okay? So 5 hours. Okay, next problem. This one's going to be a little more complicated. Like a lot more. But we've done it, we've learned it. A hot air balloon descends in a linear path. After 10 seconds, the balloon 640 meters above the ground. After 30 seconds, is 590 meters above the ground. How many seconds will it take the balloon to descend from its initial altitude? That means the highest point to the ground, 0 feet. Solving for the seconds. That's the unit of the answer. Alright, so we got feet and seconds. Seconds is X, feet is Y, and then it would be feet per second. That is unknown at this time, at this juncture, okay? Can't be sick. Wait a second, I wrote feet like an idiot. It's supposed to be meters. I apologize. Again, I do mess up, but I always usually catch it, okay? Meters per second. Okay, we don't have the meters per second. I put question marks, so it won't be 0, 1, 2. It's going to be the 0 block, okay? So meters equals Y, seconds equals X. Okay, so 10 seconds, 640 meters. 30 seconds, 590 meters. 30, 590. 0 feet, or 0 feet. That's where I got feet, because I'm an idiot. It's 0 meters, okay? That's where I got that. So 0 for meters and question mark seconds, okay? That's better. Okay, well, obviously there's a beginning amount, so we don't just put a 0. There's no way that started at 0 because it's up high, okay? When you see it decreasing like that, there's going to be a B. It says linear path, so it had to start somewhere before it went down. So you're not using your proportions. Your first order of business is to come over there and find your meters per second with Y minus Y, X minus X, okay? And that's X, that's Y. That's X, that's Y. That's why you got to label so they go in the right place. What's a higher X? 30, okay? So 30 with its buddy, the 590 on top for the y. Then 10 was 640. You can either minus or plus negative, it doesn't matter, you'll get the same thing, negative 50 over 20. Now just divide that, don't reduce it, we're not graphing. It's negative 2.5. Now you need to put the decimal, because you can go down 2.5 meters per second. Okay. I mean, distance is continuous, they can come in decimals. So that means if there was a 31st second, I would add negative 2.5 to 590. A 32nd, then I'd add another negative 2.5, and it goes on and on and on. Okay. Equals y. Well, we got b at the beginning, plus negative 2.5 times x. So I think we need to find b. Y equals m times x plus b. Now this is my m right there. That is the slope. I didn't tell you that when we first did it because you wouldn't have made any sense. But then we need an x and a y for the replacement. Okay, so let's put 10 and 640. You can also do 30 and 590. It doesn't matter. Okay, you get the same thing. So 640 goes in for y and 10 goes in for x. So 640, drop your plus, put your b. Negative 2.5 times 10 is negative 25. Then we get the negative 25 to 0 by adding. To solve for b, you'll never have to divide. So it's 665. Okay, you can put 665 there, and we know the beginning of the ladder was now 665 feet, and then when it went down by 2.5 meters per second. So 665 plus negative 2.5 times x equals y. Y equals 0. So put it in for y. You don't need to make a parentheses. The y is not multiplied by anything. Okay, let's solve for y. Plus and times. Okay. Get your 665 out of there. 0 minus 665, negative 665. Then divide by negative 2.5. Remember, a negative divided by a negative is cool because I get a positive out of it. Okay. $266 looks good to me. 266 seconds. Now, if you're one of those kind of crazy people, well, not crazy, I don't want to say that, who can't stand that, okay, well, you do ABC with 60, and that would be 4 hours and 26 minutes, okay. Actually, never mind, you could do 6 divided by 60, so you got 4 whole minutes, so you'd subtract the 4 and then you'd multiply that by 60, 26, okay. Don't do that, just saying. Okay, then our problem, scatter plot. Data below follows a linear model. Make a scatter plot for the data. Okay, so I'm going to copy down my table. Remember, this is X, this is Y. So you got years and price. 0, 530. 1, 557. Then we got 2 and 3, 582, 605. Okay, so on part A, it's just the graph and getting the data, and then that line of best fit. So X is years, this is the X, and we just need to go to 1 to 2 to 3. Now, I told you in the problem, on the y-axis, you're going to start at 5.20, because it's stupid to start at 0, okay? And then you're going to go up by 0.10 every increment. So 5.20, that's just a suggestion, so everybody's kind of on the same page. 550, some people, teachers wouldn't tell you that, okay, that's fine. 5.60, 5.70, 5.80, 5.96, and then 6.10. Sorry, this looks like crap. Okay. Okay, so 0, 530. Okay. 1, 557. 2, 582, and then 3, 605. Okay. All right, draw a trend line from the beginning point. It's not going to be perfect. Okay. There we go. Right there. Okay, I think I'm going to roll with this and this, okay? Because on part B I need to write an equation, and we're going to do that based off 2 points. Now remember, we want to make our own mini table. So M is the slope, B is the y-end. So first thing off in the corner, I'm going to make a mini XY table. X is years, Y is price. Just put years in dollars. You're going to put your 0, then block it. Now I picked the second point, so that'd be 1, 557. Don't pick the first point ever. Okay, try to avoid that. And then 2 and 582, because the first point's going to be used for something else that makes this problem a lot quicker. So that's y minus y, x minus x, okay? And I just do it with the 2 points, x, y, x, y. Now the higher x is 2, so we said 2 here. It's partner 582 on top. And then 1 with its partner 557 above it, okay? Remember the x's have to go on bottom. Okay. So it's going to be 0.25 over 1, which is just 25 cents. So that means, according to the trend approximation, it's going up by 25 cents every year, okay? Because watch, if there's a year 3, 5.82 plus 0.25, 6.10. Now that's close to 605. Remember, these are not going to be exact because it's a scatter plot. It's not an exact line. B, you can use y equals mx plus b. Well, why would you do that? You wouldn't have to even put b there, because you see I go up and look at my years and I see 530. Okay, so I know exactly what to put for b. And that's a best fit equation. Is it exact? No, but you can't get it exact when it's scattered. Okay, but it's a trend equation. Means it would start at 530, then it goes up by about 25 cents a year. About, not every year, but about.